Okay, we're going to finish up the notes that we started yesterday. And one thing that we've got to do before we can move forward is we've got to sort of step back and relearn something that we learned in Math 1. So this is a very typical Math 1 problem. Write the equation of the line that has a slope of 4 and passes through 6, negative 2. So for this particular problem, the way that I teach students how to do it is I teach them to use y equals mx plus b. And so this is your x coordinate and this is your y coordinate, and of course this is your m. So I teach students to plug in the negative 2 here, and then the 4 here for that m, and the 6 here for the x, and that way they can find their b. So negative 2 equals 24 plus b, and then we'll subtract that 24, and so we'd get negative 26 for our y-intercept, and we would end up with y equals 4x minus 26 as our answer for that problem. Now, I teach this way because I have found that students can't memorize formulas very well. And then typically when I'm teaching Math 1, I have the lower level students, and getting them to memorize another formula just doesn't work very well. So we work everything from y equals mx plus b. However, there is another way that you can write these lines that require you to know the point slope form of a line, and I don't teach this. Some teachers do. But this comes from y equals mx plus b, and if I had time I could show you, but you would probably rather me not go through that long proof of that, so if you're interested, let me know. But this formula, y equals m times x minus x1 plus y1, is a formula that we can use that will give us the line instantly. Now you have to have this memorized in order to use it. So that will require you to memorize it. We're going to use it a lot in this class, so I don't think it'll take much to memorize it. And so in this case, 4 is your m, and 6 is your x1, and negative 2 is your y1. So you're going to plug in something for the m, the x1, and the y1. You leave the x and the y in the equation. So for this case, I do y equals, slope is 4, so m is 4, times x minus x1 is 6 here, plus y1, which is negative 2. Okay, so once I do that, I could, if I needed to know my y equals mx plus b, my slope-intercept form, I could just distribute this 4 and simplify. So I could distribute the 4, and I would have y equals 4x minus 24 minus 2 right here, and then that would give me y equals 4x minus 26. And so you can see it's a little bit quicker to find that answer there. Now, it's going to be extremely quick for us because in calculus, whenever you're doing these problems, I want you to use point-slope form, and I want you to leave your answer in point-slope form. So I do not want you to solve that equation for y and get the equation in slope-intercept form, unless, of course, the question maybe asks you about your y-intercept. So we are going to leave our answer like this right here. So in calculus, whenever we see a problem that asks us to write the equation of a line, we're going to use our point-slope form. So we're using that y equals m times x minus x1 plus y1. And if I plug my numbers in here, for this problem, I would just say y equals, the slope is negative 2/3, so I'd have negative 2/3 times x. I'm going to have minus a negative 4 and minus a negative 4. I guess I'll write it just to make sure everybody's clear on that. I want to shortcut it and not write that. And then y1 is 7, so plus 7. And so this, of course, would just be y equals negative 2/3 times x plus 4 plus 7. And I could leave my answer like this if I'm going to give the equation of a line. On the AP Calculus exam, they do not care if it's in slope-intercept form. You can, as long as it's a correct version of a line, you can leave it like this. So we're going to use this primarily because we're less it's quicker and we're less likely to make a mistake. So we're going to use this on some derivative problems that we see coming up. All right. So for example 4, we are to write the equation of the line tangent to f of x equals the square root of x minus 2 at x equals 3. And so we need to write the equation of the line tangent. And so to write the equation of the tangent line, you're going to need two things. You're going to need a point and a slope. And so that point is your point of tangency. So it's that point on the graph. So like in this case, we're looking at a square root graph. It's the point right here where we're looking for that tangent line. This point right here on the graph. And then our slope is of the tangent line. And the way that we can find the slope of the tangent line is the derivative. The derivative gives us the slope of the tangent line. So this is the derivative here. So the point is really simple to find. And so to find the point, we just have to take the x value that we're looking at and plug it into the equation. So f of 3 in this case is the square root of 3 minus 2, which is square root of 1, which of course is 1. So that tells us that we have the point 3, 1 is that point of tangency over here that we see on the graph. So this is our point here. Now we also need to find our slope of the tangent line. And so to find the slope of the tangent line, we're looking at the derivative. So in this case, we could use either one of those limit definitions of a derivative that we want. We could use the one where we have the x plus h, or we could use the x minus a. Because we know which point we want to find this at, I prefer that limit as x approaches a of f of x minus f of a all over x minus a. You don't have to use this version, but I find it a little bit quicker whenever we do have that point there. So for this problem, to find that derivative here, I'm going to do the limit as x approaches 3 of f of x minus f of 3 over x minus 3. And our f of x is the square root of x minus 2. F of 3, if we plug in 3, which we really already did right here, we found f of 3, it was 1. So we subtract 1 all over x minus 3. And so now we have a limit that we need to solve. To solve this one, we're going to have to multiply by the conjugate. So we're going to multiply by x minus 2 plus 1 in the numerator and the denominator here. And whenever we do that, we are going to get the limit as x approaches 3. We're going to distribute here. That's going to give us x minus 2. When we distribute here, we get plus 1 times the square root of x minus 2. And then we get minus 1 times the square root of x minus 2, which causes those middle terms to cancel, which is what we want to happen every time. And then negative 1 times 1 is minus 1 all over x minus 3. I'm going to put some parentheses here, times the square root of x minus 2 plus 1. And we can see here that the limit as x approaches 3. This is going to be x minus 3 over x minus 3 times the square root of x minus 2 plus 1. These are going to cancel. Now we can plug in our 3, so we'll have 1 over the square root of 3 minus 2 plus 1, which is going to give us 1 over the square root of 1 plus 1, which is going to give us 2 in that denominator. So finally, 1/2 is our derivative. This is our slope that we're looking for. So the last thing that you're going to do for this is you are just going to find the equation of the line. And this is where we use that point slope form. Y equals m times x minus x1 plus y1. You don't have to write that down. I'm just writing it down to remind us what it is since this is new. And so if we plug in our slope, we'll have 1/2 here. And we'll have x minus our x1 is 3 here from our point. And we'll put a plus 1 because our y1 up here is going to be 1. And leave your answer like this. You might be tempted to distribute that 1/2 and combine, but if you do that, you might make a mistake somewhere. And if you make a mistake, then you'll lose the answer point on that, even though you have this step right. So just stop right here. We're going to leave our answer this way. All right, so let's look at another problem that, let's change this so we can see the whole problem here. And this problem asks us to do the same thing we just did, but we actually don't have work that we have to work out. So it says the graph above shows f of x, and the table above gives select values of the derivative of f, which is f prime of x. Write the equation of the line tangent to the graph of f at x equals -1. Then graph the tangent line on the graph above. So the point that we're looking at here is x equals -1. And we're supposed to write the equation of the tangent line. So we're doing the same thing we did on the last problem. The good news is we don't have an equation, so we don't have to do limit definition of a derivative. We're going to look first at the graph. And at the graph, we're looking where x equals -1. And that's this point right here on the graph. And that point is -1, -6, it looks like there. So that is our point of tangency. That is the point that we're going to use for our equation. Well, if our x-coordinate is -1, we need to know the slope of the graph at -1. And to find the slope of the graph, we need the derivative. F prime of x is our derivative. So if we see here, we've got x is -1. We've got 4 right here goes with that. So 4 is our slope. That is our derivative. That is our f prime of -1. It equals 4. That's our slope. So we just have to use that point slope formula. Y equals m times x minus x1 plus y1 here. And if we use that point slope form, y equals 4 times x. We're going to have minus -1, which is going to become a plus 1, plus -6, which is going to be -6 here. And so this is my answer. Now, it does ask me to graph this tangent line. So I could distribute if I want to here, or I know my slope is 4. So from this point, I can just go up 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. Go down 4 over 1, and I'll get this tangent line right here. Okay, so one thing that we're going to learn about, I don't think they ask about this very often on the AP exam anymore. However, they do ask it on a lot of the materials that I sometimes use, and it's really not much more difficult. So we're also going to learn about a normal line. So a normal line is just a line perpendicular to a tangent line at the point of tangency. So whereas, for example, here we are looking at a rational function. So if we think about our x and y axis, this rational function has been moved to the left 2. So it would look like this, something like this right here, and this would be -2. And we're looking at x equals 3, so we're over here somewhere. And our tangent line would look something like this. And so we're trying to find the equation of the normal line, which is just that line perpendicular to this line right here. So this is what we're trying to find. So the steps are basically the same. We just want to use the opposite inverse of our derivative instead of using our derivative here. So the first thing we need to know is that point of tangency. To find that, we're just going to find f of 3. So f of 3 is going to be 1 over 3 plus 2, which is 1/5. So that tells us that our point of tangency is going to be 3 1/5. So we have our point of tangency here. Sometimes I like to write point there beside it so I don't lose it. Now we have to look at our derivative, and again we could use either one of our derivatives. We could use the one with the x plus h, or we could use the limit definition at a point. I'm going to use the limit definition of a point on this one. So limit definition of a point, we're going to have x approaches 3 of f of x minus f of 3 over x minus 3. And so for this problem, we have their f of x is 1 over x plus 2. Our f of 3 is 1/5, so this is minus 1/5 all over x minus 3. We need to we don't need to have this complex fraction here, so these denominators, we really want them to cancel out. We can get them to cancel out by multiplying by the common denominator, which would be 5 times x plus 2. But if we multiply the numerator by that, we must also multiply the denominator by 5 times x plus 2. And so when we distribute that 5 times x plus 2, then when we multiply 5 times x plus 2 times 1 over x plus 2, the x plus 2's cancel, and we just have a 5 there. When we multiply 5 times x plus 2 times 1 over 5, this time the 5's cancel, and we just have an x plus 2. Be careful here with this minus, though. You want to put that x plus 2 in parentheses because it must be distributed. And I'm going to write this denominator this way. 5 times x minus 3 times x plus 2. And to be a good calculus student, we are going to put our limit notation here. Okay. If we distribute our negative here, I'm just going to do that here, we're going to get 5 minus x minus 2, which is going to give us the limit as x approaches 3 of 3 minus x over 5 times x minus 3 x plus 2. You can see I've got a 3 minus x and an x minus 3. These almost cancel out. So if we think of what's happening here, if I factor out a -1 out of 3 minus x, I would have -3 plus x. It would change the sign of both of these. And then I could rewrite this, -1 times x minus 3. So -1 times x minus 3 is the same as 3 minus x. So I'm going to write this way. So I've got -1 times x minus 3 over 5 times x minus 3 times x plus 2. And now my x minus 3's can cancel, and I can plug my 3 in. And when I do that, I'm going to get -1 over 5 times 3 plus 2. And of course 3 plus 2 is going to give us 5. -1 over 5 times 5 is going to be -1 over 25. This here is my derivative. This is my slope at that point. So now that I've got these two things, I'm just one step away. So I just need to do y equals my slope, which is negative 1 over 25, times x minus x1, which is 3, plus y1, which is 1/5. And I'm just going to leave my answer like this right here. I'm not going to mess with it anymore. Now, let's look at a problem where you're going to have to use that other definition of a limit definition of a derivative. So this question asks us to find the equation of the line that is tangent to the graph of f of x equals x squared plus 4x and parallel to 2x minus plus y equals 8. And so I would like to bring up my Desmos graph here. Let's pull up Desmos graph. I'm going to move this over here so it fits in the screen better. And so our equation is x squared plus 4x, x squared plus 4x, and our graph needs to be parallel to 2x plus y equals 8. And here's what I love about Desmos. It'll graph 2x plus y equals 8 for us here. And so what we want to know is we want to know where that tangent line matches this. And if you'll hold on just a second, I'll put the tangent line in. And so I've put in this tangent line here, which I have done because I know more than you right now. But what we're looking for is the place where this tangent line is going to be parallel to this blue line right here. So it looks like it's probably somewhere in here, but I can't tell for sure just by looking at Desmos. So let's look at how we can do this algebraically. If you'll remember from Math 1, parallel lines have the same slope. So the first thing I want to do here is I want to find the slope of this line. So all I've got to do for that is just solve this equation for y, which means I'm going to have negative 2x plus 8. And so my slope has to equal negative 2 here. So that's the slope of our tangent line. Well, the slope of our tangent line has to equal the derivative. So what I've got to do is I've got to find the derivative. And in this case, I've got to use the limit as h approaches 0 of f of x plus h minus f of x over h here. So I'm using that limit definition of a derivative that works for all numbers and not just at a single point. And so to do that here, I've got to do the limit as h approaches 0 of, and I've got to do x plus h squared plus 4 times x plus h plus, minus our f of x right here, which is x squared minus 4x, and all of that is over h. And just to make sure you're following me here, my f of x plus h, I'm just plugging x plus h into this formula right here, so that's this part. And then my f of x is just this part right here, and of course we just keep this h right here in the denominator. So here I've got to simplify. When I do this, square, double square here, let me keep my limit notation. I'll have x squared plus 2xh plus h squared, and I'll distribute the 4 here, so I'll have plus 4x plus 4h, and then I'll have minus x squared plus 4x, and that's all over h. And if we've done everything right, we should have some things cancel, so we got h's left. So our x squared cancels with this negative x squared, and our 4x cancels, let's see, I think I've messed up somewhere. That does not cancel. Hold on. Alright, I found it right here. That should have been a plus sign right there because should be x squared plus 4h, not minus 4h, which means over here I will have a minus 4x here, and that will cancel with our positive 4x. So we see here that everything we have left has a h with it, so I'm going to factor out an h. So h times 2x plus h plus 4 all over h. And now my h's will cancel, and since my h's have canceled, I can just plug in 0 for my x. I'm sorry, for my h. And so I will be left with 2x plus 0 plus 4, which of course is 2x plus 4. So f prime of x, our derivative, is going to equal 2x plus 4. So that gives me the general derivative. I know this derivative, that derivative gives me the slope of the tangent line, and we already set up here we want our slope of our tangent line to be -2. And so our slope of our tangent line needs to be -2. So we're going to set this 2x plus 4, we're going to set this equal to -2, and we're going to solve. So we're going to subtract 4, 2x equals -6. We're going to divide both sides by 2, and x equals -3. So there's my x-coordinate where this happens. I also need a y-coordinate. And so, you know, I already had my slope. I knew this was my slope. I knew that's what I wanted. Now I'm looking for my point. So this is my x-coordinate of my point of tangency. To find the y-coordinate, I'm just going to plug this -3 back into my function, my f of x, not into the line, because this line, all we really needed from it was the slope. We're plugging it into f of x. So we're going to have f of -3 equals, we'll have -3, oh, sorry, stop that, sorry, there we go, -3 squared plus 4, 3 squared, sorry, plus 4 times -3, which is going to give us 9 minus 12, which will be -3. So our x-coordinate is -3, our y-coordinate is -3 also. So we've got -3, -3. And so to write this equation, we'll have y equals -2 times x plus 3, because we're doing minus -3. And then we'll have plus -3, which will be just a -3 right here. So if we flip back over to Desmos really quickly, if I go right to that point, -3, -3, if I can get that exactly at -3, I'm having a little trouble doing that. -3, -3, you can see that I've got that line. I could also type in the equation that I just got. So y equals -2 times x plus 3 minus 3. And you can see that's that tangent line. It's perfectly perpendicular to this line that we found here. So your assignment for tonight is going to be these 6 problems. The first few are like the ones that I did at first, 30 and 36. 34 and 36 are going to be like that last problem that I just did.